Let's have a look now at factorising the difference of two squares. So again, the exact opposite of expansion of a difference of two squares, or that results in a difference of two squares. Now, just maybe a little warning here, I guess, or just something to look out for, that when we're expanding an expression or expanding an expression that results in a difference of two squares, you end up with an expression that's shorter. Remember, the a minus b, a plus b results in a squared minus b squared. Now, factorising is the other way around. You actually bring the brackets back in. You actually end up with an expression that is longer than what you started with. Okay, so you think factorising, hang on, that's meant to make the expression or the resulting expression shorter. In fact, in this case, it makes it longer. So don't be fooled by that. It's still factorising. So an expression in the form a squared minus b squared can be factorised into the binomial product a minus b multiplied by a plus b. So this is what I was talking about. A squared minus b squared physically takes up less space on a line than its factorised version, right? But it's still factorised. The two factors are a minus b and a plus b. So these two brackets are the two factors. You don't have to write it in this order. You could write it equally as a plus b multiplied by a minus b. Now, we've already looked at expanding these in a previous video. So this is really just going the other way around. Recall also that the two binomials that we write are conjugate pairs. Okay, remember what we meant by that? It's the same binomial. The only difference is that the second term, they have to be opposite in sign. So whatever the second term is in the first binomial, the second term has to be just whatever the sign is, but the opposite of that. So if that was a plus, this would be a minus. Okay, if that's a minus, that's got to be a plus. Let's have a look at some examples. So we can just apply a shortcut directly here, and the shortcut is that if you have a squared and b squared, the two binomials, the terms of the binomials are just the square roots of the two terms of the difference of the two squares expression. So x squared minus 1, the square root of x squared is just x, and the square root of 1 is 1. So it's just going to be x minus 1, x plus 1, and just write it as a product of the two conjugate binomials. Part B, 1 minus x squared, same basic idea. Okay, square root of 1 is 1, square root of x squared, is x, so that's going to be 1 minus x, 1 plus x. I just have a habit of writing the negative first. It doesn't mean that it's more correct to write it that way. It doesn't really matter. So if you're used to writing the positive first, then you can do that, that's fine. As long as the product, when you write it as a product, it should still end up expanding to give you the same thing anyway. 25y squared minus 16w squared. Take the square root of the 25y squared, so that's going to be 5y. Square root of 16w squared is 4w, so 5y minus 4w, 5y plus 4w. Okay, so again, it's a product of the two the two factors there. So look at some other examples. Okay, so a cubed minus a to the 5. Now on the surface, it doesn't look like a difference of two squares, but if you factorise out a cubed, maybe we could create a difference of two squares, or at least part of the expression can be a difference of two squares. So let's factorise out a cubed, okay, and we end up with 1 minus a squared in brackets. Now 1 minus a squared, it's a bit like that 1 minus x squared example, isn't it? So what's in brackets here can be factorised as a difference of two squares. So that's going to be a cubed outside of 1 minus a, 1 plus a. Okay, we'll write the conjugate pairs there. What about part E? B to the 4, or power of 4, minus 16. Okay, now this one, again, on the surface, does not look like a difference of two squares. But, well, we could turn it into a difference of two squares. B to the power of 4 is just b squared, isn't it? So that's b squared minus 16, well, the square root of 6, that's 4 squared, isn't it? So we could write it as 4 to the power of 2. So we've now turned b to the 4 minus 16 into what appears to be a difference of two squares. So we've just changed the form of it. In fact, I guess that's part of what we do in mathematics, isn't it? We take an unfamiliar expression and we try to turn it into something that actually makes sense or looks familiar, into a form that we can then work with using standard methods. Okay. Now again, we treat it as a difference of two squares. So this is going to be b squared minus 4, b squared plus 4. Okay, so b squared minus 4, b squared plus 4. After all, the square root of b squared squared is just b squared, and the square root of 4 squared is just 4. So that's factorized. But is it fully factorized? Or could we go one step further? Something like this would be worth 2 marks. For example, you would have gotten 1 mark just for writing that. So you think, where's the second mark going? Look at the first binomial. Yeah, sure, they're conjugate pairs, b squared minus 4, b squared plus 4. But look at the first binomial, b squared minus 4. Look familiar? That's another difference of 2 squares. In fact, b squared is a square number. There's a difference, there's a minus sign, and 4 is also a square number. That's 2 squared. So the first bracket needs to be factorized further into, again, a product of conjugate pairs. So this is b minus 2, b plus 2. So that's the b squared minus 4 factorized. But the second bracket there, so this is b squared plus 4, that's not a difference of 2 squares. That's the sum of 2 squares, which we can't factorize at this point anyway, okay? Unless we start dealing with square root of negatives and other sort of abstract craziness, okay? But for now, we'll just leave it at sort of as it is. What about this one, part F? 27 minus 48d squared. Now, again, it kind of looks like a difference of 2 squares, sort of. 27 is not a square number, nor is 48 for that matter. D squared is, so that's fine. So we don't have any problems with the pronumeral. But maybe we need to factorize something out first, like simple factorization or common factorization. If we do that, maybe we could come up with a form that's, again, recognizable or familiar. So 27 and 48, I guess if you divide both of those by 3, so in fact, let's factorize 3 out. So common factorization, 27 divided by 3 is 9, 48 divided by 3 is 16. So we end up with 16d squared. And again, it's a bit like part D, isn't it? Where if you take out a common factor, hopefully what's left behind is something that we can factorize further. So again, something like this, probably worth maybe 2 marks, perhaps. I'm not saying it must be worth 2 marks. I'm just saying, it could be. That would be your first mark, okay, taking out the common factor. The second mark would be to then factorize what's in the bracket. So you recognize this as a difference of 2 squares yet again. Square root of 9 is 3. Square root of 16d squared is 4d. So 3 minus 4d, 3 plus 4d. And we're done. What about part G? Okay, you've got x plus y all squared minus x minus y all squared. Now there's 2 ways that we can do this one, all right? And the first way is sort of like the manual way, is just expand both of these brackets. They're just perfect squares, aren't they? Well, we've seen those before, right? So that's your x squared plus 2xy plus y squared. This is your x squared minus 2xy plus y squared. So you could do it that way, okay? And that would work. However, there's another way we could do this is by using something called substitution. This is a very, very powerful method in algebra used to simplify an expression. It's kind of like a catalyst, I guess, in chemistry, right? Where you add a chemical. The chemical itself doesn't contribute to the final product, but it's used to help a sort of a reaction along, isn't it? So what we're going to do is we're going to introduce another pronumeral, 2 pronumerals, to sort of make this a little bit easier. So what we're going to do is we're going to let this first bracket, x plus y, equal the pronumeral u. The second bracket, right, x minus y, let's call that v. So, in fact, let's say u all squared, that's x plus y all squared, that's u squared minus v squared, okay? Ordinarily, I would write let x plus y equal u, let x minus y equal v. I did it this way so you can just visualize what I'm about to do here. So now what we've got is we have the expression now u squared minus v squared, okay? You know that u really is just masquerading x plus y, or it's kind of concealing x plus y inside of u. So think of u as a kind of like a container, and it contains x plus y. V is another container, and it contains x minus y. So by concealing that temporarily, it just makes the I guess the factorizing just that little bit easier. Then eventually we'll sort of reveal the x plus y, x minus y, and then simplify it then. So u squared minus v squared, okay, so that's really that's u minus v, u plus v. Now we can, I guess, reveal what u is in fact concealing, which is u is concealing x plus y. Okay, so I might just need a little bit of space here. So u is x plus y. Okay, so I might just put this in brackets there again. Minus v. V is concealing x minus y. Okay, so and then multiplied by. Okay, so I might just put that there in brackets. So there's your u, there's your v, u plus v. Okay, so that's again u is x plus y plus v, which is x minus y. Okay, big brackets there. If you're finding that a little bit confusing, what I might do is might actually put the outer brackets, I'll make them square brackets to make it a little bit easier for you to see this, because I think it's good for you to see what I'm doing here. If it makes it a little bit clearer for you. Okay, so use my little cotton bud eraser there. Okay, and put that in sort of square brackets there. Okay, so this is the u minus v in square brackets. Okay, so maybe I might even do the same here as well. Maybe put that in square brackets. I'm spending a bit of time on this because I really want you to see this. I think it's something that we're going to use in advanced or extension maths next year. It's going to be so handy and such a powerful method in math in algebra. So the square brackets here, so there's your u, there's your v, there's your u, there's your v. Now we can just combine the like terms, right? So I'll leave the square brackets on the outside here. So we've got x plus y minus x minus y. So x plus y. Okay, so x plus y minus x plus y. Minus y gives you positive y. Now again you got, so expanding the inner brackets, x plus y plus x minus y. Alright, now I've run out of space here, but I'm going to put the answer, alright, the answer here. So I'm just going to continue it on this part of the board there. So forgive me for having sort of go backwards here. We do that sometimes in mathematics. We realise, oops, we've run out of space and I need to... actually, I could do something a little bit different as well. How about I extend the board a little bit? Alright, that's better. Okay, sort of the beauty of using multiple boards. Alright, let's continue it on here then. Alright, so x plus y minus x minus x plus y. So the two x's cancel, and so in the square brackets we got y plus y, which is 2y. And what about this one? So you got x plus y plus x minus y. The y's cancel here, and you end up with 2x. If you like, I mean, we could just multiply the whole thing out, couldn't we? So the answer then would be 2 times 2 is 4, y times x is xy. So the end result of this whole thing, x plus y all squared minus x minus y all squared, is just 4xy.